Hey everyone, in this video we'll start on a new chapter of functions, basically a rather simple topic, and this will just be a very simple introductory video. Alright, so we're used to actually writing functions in, or writing equations in x and y, right? So let's say the linear graph, y equals to x plus 3. We can actually write this another way that's actually much easier. So we let gx or fx, right? Actually, let's just use fx because it's the standard form. So we can have fx equals to x plus 3. Basically letting y equals to fx. You can actually let use any alphabet. You know, be f, can be h, can be g. These are the common ones. But you know, for the sake of this topic, we use fx a lot more. Anyways, f stands for function is easier. So the benefit of this is now that we can actually now substitute values of x through the form of f2. We need not put x sub x equals to 2 anymore. We can now just put in f bracket 2. What this does, right, basically just replace every x with 2. So in this case, with fx equals to x plus 3, we will now get 2 plus 3 to give us 5. This has another benefit. If we don't want to have x, right, let's say we don't want to sub in x equals to a, we now have fa to give us a plus 3. For the H2 Math syllabus, you'll be learning how to actually substitute x with another function. So for example, we now have fx squared plus 1. This basically means replace every existing x with x squared plus 1 to give us x squared plus 1 plus 3, x squared plus 4. Alright, so if you're the H1 and A Math student, this is pretty much it for the functions. However, if you're H2 Math syllabus, well, it's time to learn more. Alright. So one way to represent functions is actually not by this form, actually why I didn't draw the line. It's actually use a different form. Instead of using brackets and equal sign, we'll use colons and arrows instead. So we have f colon x arrow with a vertical line, x plus 3. Alright. Now, this is the exact same meaning as the one above, fx equals to x plus 3. Alright, so this, right, is important because if the question starts with this form, they would usually expect you to express your answers in similar form. Alright, so this is important. Okay, if they write this down in similar form, then use this notation. Alright, otherwise you can use either. Alright, preferably the first one because it's easier. Okay, so do take note, right? It's an important notation, and it does come out. Alright, and many people have made mistakes because they did not express their final answers in similar form. Alright, so do not lose mistakes. So do not lose marks, right, because of this simple mistake. Alright, so from here, right, another thing in the H2 Math syllabus that you need to know is the idea of domain and range. Alright, so we have domain, which is basically represented as df, right? Domain of f. So what is the domain of f? Domain of f is basically the range of values of your input. In this case, your x, right? Range of values of input that is valid in the fx. Right, so let's say we have fx equals to 1 over x plus 2. Right, we know that x cannot be minus 2, right? So therefore our domain of f is basically negative infinity to minus 2 union minus 2 to infinity. Alright, so you have to be very clear on this. For the domain, right, you use very common things like union, equal sign, or a subset of. But if you're looking at the exact domain of a function, this is an example. Alright, so the range of values of your input that is valid for x. Your range, right, will be the opposite. Alright, again, range, we can represent it as rf. It's not the range of values of fx, right? Basically your output. Okay, so for every valid x, right, so basically out of your domain. Okay, So let's say we have an example. Let's say we use the original example. Okay, use this one actually. Fx equals to 1 over x plus 2, right? We know that x cannot be negative 2. So for this function, we know that the range of f is basically negative infinity. Sorry, it will basically be, negative infinity to infinity, all right? But let's say if we have another example, let's say we now have gx equals to x plus 3, but now we shrink the domain to, let's say, x between 2 and 3, right? So g is now between 2 and 3. Our range of values of g, now is rg, will simply be 5 and 6, right? Because we know that this linear line is always increasing. So the minimum value occurs at x equals to 2, which gives us 5. The maximum value occurs at x equals to 3, which will give us 6. All right. So this is basically domain and range. All right. Now, lastly, we have what we call by composite functions. Okay. So composite functions, you can probably tell by the name, right? It's basically where we substitute the x with another function or the same function. Not composition, composite functions. Okay. So a common example would be f2x. This basically means we have f and then we replace all x with fx. Okay, and obviously if we continue this further, it will be f3x would then be f of fx. Okay, and it goes so on and so forth, right? Another way to do it, although there are some conditions that need to be fulfilled, which I will go through in future videos, we have fgx. All right, this basically means f and then replacing all the x with gx. Okay, so for example, if we have fx equals to x plus 3, it will simply be gx plus 3, and f squared and f2x will simply be fx plus 3, which will then be x plus 6. All right, so this is basically an introduction to our functions. Yeah, that's about it.